Alright, so in this video, I'm going to solve the equation 1 to the power of x is equal to 2. So, before we even start solving this, if, let's say x is equal to 1, then I have 1 to the power of 1, which is equal to 1. And if x is equal to 2, then I have 1 to the power of 2, which is also equal to 1. And you can go even 1 to the power of 10 is still equal to 1. So you may be thinking, what possible value of x can make 1 to the power of x equal to 2? So let's try solving this. What I'm first going to do is start by taking ln of both sides. So I get ln of 1 to the power of x is equal to ln of 2. And ln is the same thing as the natural log. And the reason I took the ln on both sides is because it comes with a property that states that if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this turns into b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front. So I get x times ln 1 is equal to ln 2. And you may be thinking, we could just divide both sides by ln 1 and x would equal ln 2 over ln 1. However, the only problem with this is that ln 1 is equal to 0. And remember, anything divided by 0 is undefined, so this would be undefined. So we know that this equation has no real solution, but it could still have imaginary solutions. So to actually solve this, I'm going to use something known as Euler's formula. And basically what this formula is if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know to many of you watching this video, this may just sound like a bunch of gibberish, but just hang on. So let's say that theta is equal to 0, right? Say that theta equals 0. So now I get e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. Cosine of 0 is 1 and sine of 0 is 0. So I get this all is equal to 1. Now, what if we say theta is equal to 2k pi? And k is just a substitution for all real numbers. So now I get e to the power of I times 2k pi is equal to 1. Because all we did was we just substituted theta in for 2k pi into this same thing. So now, because this is equal to 1, we can remember our first equation, which we started with 1 to the power of x equals 2, we can substitute in this for 1, meaning I get e to the power of I times 2k pi to the power of x is equal to 2. So just think of this as 1. So I have basically 1 to the power of x equals 2. And now, with this, I'm going to take the ln, or natural log, on both sides. So I have ln e to the power of I times 2k pi to the power of x is equal to 2. So I'm going to now bring this x down using the property of natural logarithms. So I get x times ln e to the power of I times 2k pi is equal to 2. is equal to ln of 2, because if you take ln on one side, you have to do the other side. And now I can also move I times 2k pi to the front. So I have I times 2k pi times x times ln e is equal to ln 2. ln e is simply equal to 1. So I get x is equal to ln 2 over I times 2k pi. And now I'm going to multiply this by I over I. So I get x is equal to negative I times ln 2 over 2k pi, because I squared is negative 1. So this is my solution. Alright, so in this video, I'm going to solve the equation x to the power of 2 minus x to the power of 3 is equal to 80. So, to solve this equation, I'm going to first start by subtracting 80 on both sides. So now I get x to the power of 2 minus x to the power of 3 minus 80 is equal to 0. Now from here, I'm going to replace 80, negative 80, I should say, with negative 16 minus 64. Now, I'm going to rewrite this as, I'm going to first rewrite negative 16 as negative 4 squared, and negative 64 as negative 4 to the power of 3. And I'm going to group x squared with negative 4 squared, and x to the power of 3 with negative 4 to the power of 3. So now there's two properties that I'm going to use. And before that, I'm going to write this as x squared minus 4 squared, and I'm going to group this minus x to the power of 3 plus 4 to the power of 3. We put this plus because this negative sign distributes. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And if I have something in the form a to the power of 3 plus b to the power of 3, which is this is equal to a plus b times a squared minus ab plus b squared. So for x squared minus 4 squared, it's going to turn into x plus 4 times x minus 4. I have this minus a to the power of 3 plus b to the power of 3, or in this case, x to the power of 3 plus 4 to the power of 3 is going to turn into x plus 4 times x squared minus 4x plus 16. Now, because both of these terms have x plus 4 in them, I can factor out x plus 4. So I get x plus 4 times x minus 4 minus x squared minus 4x plus 16 is equal to 0. Now from here, this is equal to x plus 4 times x minus 4 minus x squared plus 4x minus 16. I just distribute the negative sign, is equal to 0. And let's simplify this even more. I get x plus 4 times negative x squared plus 5x minus 20 is equal to 0. So I get two equations from this. I get x plus 4 equals 0, and negative x squared plus 5x minus 20 is equal to 0. So first, for x plus 4 equals 0, all we have to do is subtract 4 on both sides, and we get x is equal to negative 4. Now, for negative x squared plus 5x minus 20 equals 0, well, first off, we have a negative sign in front of x squared, so I'm actually going to get rid of that by multiplying both sides by negative 1. So I get x squared minus 5x plus 20 is equal to 0. And now, to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 5, and c is 20. So I get x is equal to negative of negative 5 plus or minus the square root of b squared, which is negative 5 squared, which is 25, minus 4 times a, which is 1, times c, which is 20, all over 2a, so 2 times 1. And this is equal to 5 plus or minus the square root of 25 minus 80 over 2, which is equal to 5 plus or minus the square root of negative 55 over 2. Now, this is equal to the square root of 55 times the square root of negative 1 over 2. And the square root of negative 1 is equal to the imaginary number I. So I get 5 plus or minus the square root of 55i over 2. So this is 2 more solutions to this equation. Thank you for watching. Please make sure to subscribe, leave a like, and share this to any of your friends and family.